Hi. My name is Edward Greve. I'm the head of engineering at Iota Foundation. I've been working in sort of the Iota community for about a year. I officially joined the foundation at the beginning of this year in January. We're doing a lot of interesting things at the Iota Foundation. I know this talk is supposed to be about platform scalability. I'm going to talk about that a little bit, but I also want to give you a sense of what Iota's vision is about and what the foundation's purpose is. And because this is a developer conference, I have some slides I want to show you, a really quick, simple demo just of sending an Iota transaction. Let's get some code up on the screen there for our developer friends in the room. I want to encourage you all, developers here, to go back, download our libraries, try it out, and join our community. So I want to first talk about the vision. And I think I really appreciate the words from Song Ji-hyung this morning. It's very much in line with the way that Iota Foundation thinks and the principles of Iota technology, why it was developed. Especially what struck me really was this metaphor about the mud roads and the horses being better for mud roads, but it took a long time to build the infrastructure, those nice, smooth, paved roads before we could actually have the automobile industry begin to develop. And I think Iota in particular is a little bit different from other blockchain technologies. We don't just want to provide a standard blockchain that you can use as a ledger. We market ourselves as the backbone of the IoT. Of course, we're very focused on IoT. It's in our name, Iota. And we hope that Iota can actually become that sort of paved road infrastructure that can really help push distributed computing, distributed information transfer and value transfer and all that into the next age. And I think right now, the current status quo of blockchains built on the cloud, on Amazon, on AWS, on Google Cloud, it's not really getting us there, right? If your nodes, if your blockchain services are all provided by Microsoft and AWS, where's the decentralization? So that's really what we see in the future, and we hope to use Iota for that purpose. So let me dive into some examples of Iota's vision. The first one I want to talk about is Iodophor Mobility. So if we're thinking about that backbone infrastructure for IoT, you can think of a connected car as an IoT device, and the car could have an Iota wallet in it. And wouldn't it be cool if your autonomous car, which can drive itself, could also act as its own, we call it, autonomous economic agent? So right now, we have all of this stuff going on in AI, in machine learning, in machine autonomy. And one of the big factors that's missing from the machine realm is economy, right? It's very difficult for machines to take out a $1 bill or a 10,000 won bill and give it to somebody. And they need tokens to do that. That's why we have stuff like Bitcoin and Ethereum. But there's problems with the traditional blockchain. They're not typically good at doing something that we might consider like a cash-based transaction. And so this is one of the main goals of Iota, is really to think about how can we build a cache, so to speak, for machines, where a machine can go, like a car, can drive to the garage. And of course, because it's an immutable ledger and it has data integrity, you can store stuff like maintenance records on there. But then you could also use the same system, that same IoT backbone, to pay for the maintenance directly from the car. And when I say pay for something directly in Iota, it has a very specific meaning. Typically, when you make a payment with something like Ethereum or Bitcoin, a developer would write an application makes a transaction record, the transaction gets sent off to the cloud, and it gets distributed out to the nodes. This is also true for Iota right now. All of our nodes currently on the public mainnet, they also run in the cloud. But what we're hoping to achieve in the not too distant future, I should say, is that you'd be able to pay directly to the opposite party, the receiver of payment. And we have some demos of this already. So even with automotive industry, we have some demonstrations set up with electric vehicle charging with one of our partners in the Netherlands. And while you're charging the vehicle, so you plug the vehicle in, and while you're charging it, you're actually paying for that electricity directly to the payment pump's wallet over that wire, and it never touches the internet. And that's really what we're talking about when we talk about distributed networks. We're not talking about a cloud-based infrastructure. We're talking about something much more distributed than that. And of course, like I said, we're not there yet, but that's what we're shooting for. So you can imagine an autonomous vehicle that drives around, keeps track of its maintenance records, pays for them, is able to pay for its energy, is able to find and pay for parking directly and autonomously. It's an autonomous economic agent. Another use case that we like to consider, and we have a team working on, is supply chain. And supply chain is a very complex topic. I remember hearing some story that in order to ship a container of apples from some country in Africa to some country in Europe, there were hundreds of different communications involved. You had to stamp at customs agencies and producers and buyers and sellers and traders. And there's this whole long chain, right? We call it the supply chain, where every party needs to have records from every other party. They all need to be authenticated. Wouldn't it be great if that could happen on a distributed ledger, where customs agencies, for example, could just look and see the records in the ledger and know that they were authentic? And of course, maybe this is something you can say, well, you can do this with any blockchain technology. But we don't think so. And there's a couple of reasons for that. One of them, of course, as I just mentioned, is the truly distributed nature of it. If you have goods and services that are being shipped or are in remote areas, there may not be great internet accessibility. You may need some more localized capabilities. Another one, of course, in Iota in particular, is that as far as I know, we're the only fee-free token transfer system around. So you can actually transfer Iota tokens without a fee. There's a very small amount of proof of work that you do to transfer tokens, but you do it yourself. So the proof of work is, in its traditional blockchain, proof of work is centralized in mining farms. In Iota, the proof of work is also distributed to the users. And so when you generate a transaction, you do a little proof of work, and you can send your transaction for free. And what that means is, if you're doing something like this case, where you're just sending lots and lots of authentication data, you can also send that data for free using the Iota Tangle. Another use case, if you think about starting to put some of these things together, and this is maybe one of my favorite ones, Iota for cities. It's very cool to think about the future smart city, where it doesn't depend on very centralized agencies to run its economy, to run its energy supply systems and all of that. So let me pull some of these things together. So in the first example, we talked about autonomous economic agents like vehicles. A vehicle can charge and pay for its own energy at an electric charging station. It comes home at night and it parks in its smart city garage, and it has some excess electricity in its battery that it's not using at that time. Why can't we make use of that? Well, right now, that energy is kind of stuck in there. There's nothing, you could sell it back to the energy company or something, but then there's this whole long, complicated path and mechanisms and regulations and all that stuff. What if your neighbor who needed the energy to run his computer or lights or whatever could just buy the energy directly out of the car? Wouldn't that be cool? So you go charge your car up, you park it at home, and your neighbor can automatically buy the energy out of your car. You don't have to know each other, you don't have to trust each other, you don't have to do transactions over the internet. It opens up all kinds of worlds that you can think about, all kinds of use cases. So this is kind of our vision. I have a short video to just give you a little bit. Okay, yeah. So maybe I just mentioned this. So in Iota, we always talk about machine-to-machine economies. This is what we're talking about, right? All this kind of stuff. Machines being able to communicate, buy and sell, do data validation and data and value transfers directly with other machines. And of course, we build all this stuff for people. We're a very people-centric organization. I'm going to talk to you about that in a little bit. But first, let me just show you this video about Iota, the ledger of everything. This is another use case example for Industry 4.0. So could you play that video?
Iota. Iota, the first open-source distributed ledger that is being built to power the future of the Internet of Things. The technology empowers smart manufacturing with feeless microtransactions and data integrity for machines. Cryptographically secure in a decentralized way, and with communication happening machine to machine, Iota is being used for any sort of information transfer during the production processes in the smart factory. In the future, a digital twin is stored in the Tangle and is a digital representation of everything in the factory. This ensures that a machine is running the correct software, enables continuous and precise data analysis, and predictive maintenance. In the factory, machines are acting autonomously, earning and paying digital money for their services and exchange of material and other resources in real time. This fully interconnected system reacts to its condition and performs instant self-optimization. As material is handled and transformed into parts and components, the data follows the material. Effective and transparent operations resulting in massive efficiency gains and quality improvements. Iota technology provides trust in this steady flow of data. A secure and tamper-proof audit trail for the machine's operations is established. Iota is fast becoming a key enabler for this Industry 4.0 vision. Please contact the Iota Foundation to collaborate around the most inspiring and groundbreaking industry transformation in our lifetime.
So there you go. Kind of to give you a sense of this vision that I'm talking about, right? The ledger of everything, and it really is from where we're sitting. It's meant to be, and we hope that it will be this IoT backbone, this smooth paved road surface that really provides the infrastructure that we need in technology to make decentralization really possible. So I want to talk a little bit about the foundation and the organization that does most of the development work on the Iota protocol. We're a nonprofit foundation. It's been registered in Germany since just last year, so it's very new. It's less than a year old. And I just give you some numbers about the Iota Foundation. We currently have about 80 employees. That's up from, well, 0 in November, but there were probably 5 or 10 working. We're adding people very rapidly, so we're hoping to get to like 100 probably by the end of the year. We've received donations of $100 million to date. That's all in the form of tokens. In Iota tokens, we did not do, when Iota was originally done as a crowd sale, there was no withholding percentage for something like the Iota Foundation to run. It was, the crowd sale was complete, all the tokens were sold, and the Iota Foundation was formed after the founders asked the community for donations. They said, if you want to support this project, you should donate some money to us to run it, rather than keeping some money for themselves up front to run the project. So that money was all donated. We have a very active community. We're on all the different popular platforms. We've got developers working on it every day, and lots of different projects going on. And we have an ecosystem development fund that was also funded by community donations that we use to give grants and support Iota projects that are going to help drive the open source, community open source adoption. So the Iota Foundation really believes in this future machine economy vision. And we want to get there through collaborative open work, right? So we're all about co-creation, we're all about transparency, we're all about decentralization, and we're very consistent internally and externally. We're not at all about making money for us. This is about developing that technological backbone. And we know that just like with the internet, you need to have open protocols, like for example TCP/IP or something. You need to have open protocols that other people can contribute to support that kind of infrastructure. So we don't expect to get rich off it, but we just want to make this technology something that actually works for the real world. And we're always on the lookout for developers, businesses, academic institutions, research institutions that want to help come with us and collaborate and help us build this infrastructure. So that's something we're always doing. We've done quite a bit in just the short history. So this goes all the way back to the original design and crowd sale in 2015. We're working with a lot of big names. You can see it's kind of blurry in the box there. And some of these are actually really working, have dedicated teams to working on Iota stuff. Hannover Messe, back earlier this year was great. There was a demo in Germany where there were many dozens of proof of concepts of buying like drinks mixed by a machine in real time by paying with Iota. There was all kind of cool stuff going on there. So even though the technology is still early stage and still all of our nodes today, like I mentioned, run on your standard basic cloud providers, people are actively pushing this IoT vision. The people that share it with us are actively helping us to push that. So that's a little bit the vision and the about where we see scalability going in the future. A little bit about Iota Foundation and a call to action to come talk to me after this and see how we can cooperate. And I just want to take a few minutes and run through a super basic dev demo because Iota's really fun and easy to use. And I hope there's a lot of developers in the room who will find this useful. And I can explain a little bit about Iota Tech while I'm doing that. So the first thing, I'll just give you a brief overview of some of our recent stuff. This has all come out in the last couple of months or is actively being developed now and will be released soon. So we have a beautiful new wallet. It's on all the platforms, mobile, desktop, Linux, Windows, whatever. And that wallet helps you manage your tokens a lot more easily than the previous wallet. If any of you have Iota experience, you'll know that the previous wallet was not that great. It's a little bit tricky to manage tokens in Iota because Iota is built for machines. It's built for the machine-to-machine economy. And so the human aspect of that is a little bit more tricky to integrate. But our team has done a great job with Trinity. And the reason it's called Trinity, by the way, is Iota is developed using trinary math. So we actually use base 3 math to balance trinary minus 1, 0, and 1. And so the wallet is called Trinity. There's a lot of 3 theme in and around Iota. The Iota Hub enables payment processing for Iota tokens. It makes it very simple. It makes it more or less as easy as any other blockchain. We've actually been working with the developers here at Upbit to help them integrate the Iota Hub. And we have some other stuff that's coming soon. The C client in particular is one thing that we want to push out in the near future. It's already open source, but it's still in development. And that's something that we need for low-powered devices. Right now, the Iota node software is written in Java. It's kind of bulky. It's not very modularized. So we're trying to take care of that with the C client. And one early-stage project that was announced earlier this year as well is Cubic that enables smart contracts and outsourced computations. And it's quite a bit different than your traditional smart contracts. Like in Ethereum, you need the entire network to run a piece of code. It's very inefficient. But with Cubic, we use quorum-based computations. That's why there's a Q, because it's quorum-based, actually QBC, quorum-based computations. And so you only need a very small portion of the nodes of the network to run a computation to get a good enough cryptographic proof of its legitimacy. And there's lots of other projects that are ongoing, and we're always welcoming open source contributions to that. All of our projects are open source. Okay, so let me give you a quick dev demo here. We're going to look at one of the client libraries, the JavaScript library. It's actually the new JavaScript library is in beta right now. Partially written by me, so that's why I'm showing it, I guess. But you can go to docs.iota.org and check out all of our developer docs. So super simple. You're just going to go ahead and npm install @Iota Core. That's our new organization is @Iota. All of our stuff is now like modularized, really nice and easy to use. And then you're going to go ahead and pick a node. And for my purposes, I'm just using the DevNet. It's a network that does not, I mean, there's tokens on there, but there's no value associated with them. I don't think anybody's trading DevNet tokens. It's probably a very bad idea. The network is often under maintenance or being upgraded or downgraded or bugs or whatever. So, but anyway, it's good for development. And so we're going to open up an Iota object with our DevNet node. And then I just do a quick call to get node info and show some of the information you can see about the node. So you can see the version number that it's running and a bunch of information about it. Tips down there, 81, that's an interesting one that I'll talk about in a few minutes. Neighbors, you can see the number of nodes it's connected to and so on. So now what I'm going to do is go ahead and generate a seed. And a seed in Iota is represented in base 3. Usually there's some kind of like, for Bitcoin, like some base 53 encoding or whatever. In Iota we use trinary, and so we use base 3 encoding. These letters and the number 9 here that you see are called trites. So each one is 3 trits. One trit is like a bit, -1, 0, and 1 again. And so 3 of those are packed into each one of these alphanumeric letters, and here's my seed. It's just a random 81-character string. And in Iota, because we're really looking ahead and looking towards the future of cryptography, the future of computing, we have a very unique signature scheme. It's based on a Winternitz one-time signature scheme. And a one-time signature scheme essentially means that what you have to do with this private key is generate what you have to do with this seed is generate multiple private keys. So you can't use this seed to sign transactions. What you do is generate private keys with the seed, and then you use those private keys to sign transactions, and it's only one time. So one private key is used to make one address, and one address is used to sign one transaction. And this makes us quantum secure. So in the future, again, we're very forward-thinking. In the future, when quantum computers are commercially available and all of that, Iota will absolutely be secure, whereas some traditional cryptographic techniques may not. So anyway, here I'm showing that we take the seed and we generate an address from that seed. And so here's my address, this KIA, Kia, I guess it's like the Korean car company. So I'm going to take my address and go over to the Iota faucets and just get some tokens to play around with. So you can, it's faucet.devnet.iota.org. It might be down right now, but I'm sure they'll fix it soon. And then you're going to paste your address in here and get some tokens. And so after I've done that, I'm going to go back in the code and plug my seed in there, and I'll be able to get my account data. Now remember, one address, one transaction, one signature, and this is all happening multiple times within a seed. So there's this utility function called getAccountData that's able to look at all the addresses of a seed and collect their balances together, so you can see the full balance and transaction history pretty easily. You don't actually have to remember, as a developer, all of those separate private keys. You just remember the seed, and you're good to go. So we can look that up, and here's the results. And you can see I've got a balance of 1,000, and here's going to be a list of all of the transactions that were made with addresses generated from that seed. And you can also see in these, by the way, that all of the encoding of the hash, address, everything, branch and trunk transaction are encoded in that same trinary scheme. So A through Z plus the number 9. And so I'm just going to go check the address here. Sorry. So I'm just going to go check this address as KIAN. Actually, I used a different one when I was generating the slides, but I just check it, and there's my 1,000 Iota balance. So that was received from the faucet. And then I'm going to go ahead and make a transfer and send some tokens to another address. It's pretty straightforward, and I'll just talk a little bit about what's happening here. So the first thing we do is make our transaction object very straightforward. Address, I'm going to send 20 tokens to address KIAEN. And I need to pick a depth and a min weight magnitude. And you're thinking, what is that? So in Iota, we actually don't use a blockchain. I know we're at a blockchain conference. Everybody's talking about blockchain. In Iota, we use a little bit different data structure. It's called a DAG, or DAG, or Directed Acyclic Graph, if you want the technical term. And that graph connects transactions directly with one another. So in a blockchain like Bitcoin or Ethereum, you take a whole bunch of transactions, you package them in a block, and miners will validate blocks at a time. In Iota, we don't actually do that, because we're trying to go for totally distributed consensus. What you want to do is, as a user, find 2 other transactions, any 2 that you like, and pick those and validate them. And so this depth and min weight magnitude, the depth in particular, is going to tell me how far back in the graph I go, and min weight magnitude will tell me how much proof of work I do. So remember, I mentioned earlier that in typical Bitcoin, Ethereum style blockchain, you have these mining farms doing proof of work. In Iota, I'm the user, I do proof of work, and min weight magnitude is simply how much proof of work do I have to do. So then I go ahead and make this really simple 2 calls here: prepare transfers, and I'm going to prepare it with my seed and this transfer object, and then send trites there on the next line. Iota.send trites is going to actually send the transfer, and the result at the bottom, this hash here, is my transaction hash. I'm done. I don't have to wait for I don't have to wait for it to go into some mempool and be picked up and mined by some mining block. I mean, it's done already. So we can check and see actually those 20 IOTAs. This is the really key takeaway from this. Those 20 IOTAs were received over here, right? So you can see I sent 20 IOTAs. I received 20 IOTAs, no fees, right? That's the beauty of it. And by the way, when I was doing this demo and tried it out, this transaction took like 5 seconds. So it's can be very quick. It's not always, depends on the network state and how many people are trying to attack it at any given time. But when it's working smoothly, it takes just a few seconds, and I get a zero-fee transaction, end-to-end, super straightforward. So I hope that all the developers in the room will go home and try this out. If you have any questions about developing for Iota, I've had some already just talking outside. I know our documentation is not perfect, but we're working on that. But feel free to ask me. Feel free to go home and try it out and join our communities and take a look at our projects. We've got plenty of stuff going on. We're also hiring, of course, so feel free to go to jobsiota.org. We would also hire in Korea. It's not a problem. We're all distributed around the world. And even before you do that, you can come over to our Iota Discord, Reddit, Stack Exchange, and find us and have a chat with us. I'm on there all the time. Feel free to ping me. So I guess that's pretty much it. I just make one last brief mention for the developers in the room again. If you have an idea for a project, you think Iota might be a good platform for your project, please apply to our Ecosystem Development Fund for a grant. If it's something that can contribute back to our open source community, we'll be happy to consider your application and help fund your project. So thank you. I guess I have some time for questions.
Yes, thank you very much, Mr. Greve. So we will have a Q&A session, and there are many questions to you, Mr. Greve. One of them is, what is realistic maximum TPS after removing the coordinators? Tangle tells TPS is infinite theoretically, but now Tangle cannot show the high TPS, so I have my doubts about the opinion.
Right, so if you remember back to what I mentioned at the beginning of the talk, Iota being developed for this fully decentralized network. So in the future, we're looking at Iota that does not depend on going through the internet. And it would be direct machine-to-machine communication, wallet-to-wallet transfers, just like cash. And so in that sense, in that time, hopefully we'll get there. It's still being worked on. We invite you to come work on it with us. There have been claims made in the past that Iota has infinite TPS if you can achieve that kind of offline transaction direct payment mechanisms. Of course, that's difficult. For now, realistic maximum TPS after removing the coordinator, we're aiming for, I mean, it's hard to give an exact number on it because it hasn't been implemented yet, so we don't know. Our own personal goal is 1,000 TPS. I don't know if we get there or not. I hope so. But that's still significantly higher than most other tech that's out there. So.
Okay, thank you for your kind response. And the next question is, I think that the blockchain core is the state machine. In that sense, IOTA's Tangle structure looks like that very difficult to summarize whole state or reference balance state. So what is the IOTA solution for that?
Right, and so this is actually, it's actually a doubly interesting question if you think about the one-time signature problem or concept, however you want to put it. So one-time signatures means that actually, as a user, I have to now store some state, which private key I'm using outside of the Tangle. So there are a lot of state questions around Iota, but again, it was developed to provide that backbone layer. So it's not necessarily the case that everything that you do on the Iota ledger will always be stored permanently forever. However, the stuff that is on the Tangle at a given time is verifiable, right? So if you think like, let's look at the internet generally. When you make an internet request via HTTP and it goes to some DNS server and gets routed somewhere, so those servers are not all keeping that request all the time everywhere, right? It's not like every internet request and response that goes around is being kept all the time everywhere, because the internet and these protocols are this fundamental backbone layer. They're not also providing storage and monitoring and everything else, right? You have to implement that on top of the basic protocol. So Iota is much more like a basic protocol. in that sense. Now, as for the balance state, there is it's a little bit technical. If you look on our Iota Ledger GitHub, there's a repository on there called snapshot.ixi. IXI stands for Iota Extension Interface, and snapshots are what we use to reference the full balance state. So I assume that the person who asked this question is a little bit familiar with the tangle. So you pick a transaction, and what you can do is work backwards through time and figure out all of the balances, all of the account balances at that particular transaction, and then you can do whatever you want with that. You can keep it somewhere and use it as a reference for later. We actually, Iota Foundation, perform what we call global snapshots once in a while, which allows node operators to delete their history if they choose, and keep their nodes very small. And the balance state is kept in that basically a UTXO file.
Okay, thank you. I think there are many interests in Iota, so there are many questions remaining to you. So I would like to pick up one of them. The next question is, when can I expect Iota Coordinator is to be deleted?
Deleted, oh, I like that, so let's delete it. So we usually use the word turn off, but delete is fine as well. So the coordinator, if you don't know, right now Iota is not, as our future vision depicts, a fully decentralized platform. It's mostly decentralized, but we have one process that Iota Foundation currently maintains. It's called a coordinator. The reason for the coordinator's existence is that in a graph structure like Iota, where you don't have definite blocks, it's very easy for an attacker to do a splitting attack, where they basically split we call it the tangle, but this graph structure into different branches. And so we have a coordinator which essentially picks one of those branches more or less at random. And that's to keep everybody on the same track. So there's a lot of misconception about what the coordinator actually does. It doesn't manipulate anything. There's nothing funny going on behind the scenes. But what it does do is pick which branch the tangle should grow in, and people like exchanges or developers or companies or anything can use that chosen branch as a reference point. They don't have to. The stuff in other parts of the tangle is still perfectly legitimate in terms of being verifiable or whatever. The only thing that's different is that you can't calculate a balance that's not been approved by the coordinator. So to answer the question, it's an active research project. We actually call it coordicide, so killing the coordinator. We hope to do it very soon. It's been a thorn in our side, but we have a great research team that's actively working on it. And right now, the main issue, just to give you a sense, when you have these long splitting attacks where the tangle gets split into different branches, you need to know, as a user, how far back in history do I have to go to be very certain that I've picked a good branch. It's a very difficult problem. Our team will be more than happy to discuss with you if you want to research. If you want to help us, come look at it, or you have a research arm or anything that's interested in it. We're hoping to get it a coordinator-free version of the tangle operating on a testnet by the end of this year. So for mainnet, I don't have an answer, but for the testnet, we're looking at the end of this year.
Okay, thank you very much. I would like to ask one more question.
Sure.
The next question is, how do you plan to manage the size of Iota DAG, which is plus 50 GB? It doesn't seem appropriate to fit into a IoT product, which usually contains limited amount of hard disk.
Yes, very good question. So again, I want to emphasize, because some of these questions, they're very important, and they're things obviously that we're aware of, that we are working on. But again, you have to consider these kind of issues in the context of building out this brand new infrastructure, right? So we're not providing a solution that's meant to be used ultimately on cloud storage or whatever. It's ultimately meant to be used on IoT devices. And so at the moment, it's used on cloud storage, and this is typically not a problem, something like 50 gigabytes. But for IoT devices, then of course it's a problem. So there's a couple of ways to look at it. One is that in the immediate future, in the near-term future, and what people are doing today, is using different pieces of Iota on different pieces of technology and hardware. So you may have hardware that does transaction selection, validation signatures, and then does not store the history of the tangle, but rather that piece of hardware will send that transaction to a larger computer with a larger hard disk that could store that transaction. So that's one way to do it, is to actually split the functionality of IOTA into multiple hardware components. Another way to do it, which we're working on, I mentioned it on one of the slides, I didn't mention it, but it was on one of the slides, is what we call local snapshots. So that UTXO list, the snapshot balance state that we just talked about a minute ago, what we want to do is give node operators the option to do those snapshots at any time. So if you're building an IoT device and you only have 100 megabytes of storage instead of 50 gigabytes, you can do snapshots as regularly as you need to keep your database size to a minimum. And right now, by the way, that UTXO balance file is like 20 megabytes or something, so it's not super huge.